Great, oh, that was very wobbly. Right, question 6. The table shows, Dom, it doesn't show Dom. The table shows an incomplete dynamic programming tabulation to solve a maximum path problem. Complete the working and suboptimal maximum columns on the copy of the table. Right, well this was easy, wasn't it? So this was a really straightforward 6 marks to start with. Really, it should have been, shouldn't it? Because the table is started for you. That's exactly what we want. There's nothing that we need to look up. You just need to remember how dynamic programming works. So we've got the first half of the table done. So in stage 1, state 0, now this action is given as being 1, and we need to use the value from the 0 bit in the previous part of the table. So that's going to be a 3, which gives us a 4 there. This one is action 1, which means we're looking at state 1 up here, which was a 4. So that also gives us 4. And we're choosing the maximum out of those two numbers, which is 4. Does that make sense? The next one we're looking at we're looking at action 0, so that means state 0 in the previous stage, and that's a 3. Action 1, so state 1 in the previous stage has a number of 4, so that gives us a 5, and we're choosing the suboptimal maximum, so we're choosing number 5 there. Interestingly, when I did this, I initially made a slight mistake and added 1 plus 4 to get 4. I then spotted my mistake and changed it to be a 5. So on my little one that I did when you were doing this, and I noticed it immediately, but just after I'd written the number. I think 2 people did 1 plus 4 and got 4 at that point, and so ended up with 4 as the value at this stage. Interesting. Down here we're doing action 0, so we're looking at state 0 from the previous stage. That's a 4, and that was a 5. 2 plus 4 is 6, 2 plus 5 gives us 7, so we end up with a value of 7 down there. Now that's it, that's the table completed. Brilliant. The question also said, let's make sure that we get all of those little bits that the question's asking for. It said write down the weight of the maximum path and the corresponding route. So quite a few people then forgot to write down that the weight of the corresponding path is 7. It's there in the table, but you have to actually state it because the question said state it. And it said give your route, write down your route using stage state variables. So the route is 0, 0. And then 0, 0, it was the 1 that we chose, so that means it's then 1, 1. In that bit, it was the 1 that we chose again, so that makes it 2, 1. In 2, 1, we chose the 0 option, so that makes it 3, 0. And in 3, 0, we chose the 0 option, which makes that 4, 0. What a number of people forgot is that even though there wasn't a 4, 0 in the table, there must have been a 4, 0 for there to have been a stage 3 when we start. So quite a few people forgot to put that 4, 0 on at the very end. And that was a mark lost. So you see, out of 6 marks, a number of you lost a mark for not putting 4, 0, a number of you lost a mark for not putting 7 explicitly as the weight, and already you've done everything right and you've got 4 out of 6 instead of 6 out of 6, and that's frustrating, isn't it? Then it says Ken has entered a cake making competition. The actions in the dynamic programming tableau represent the different types of cake that he could make. Each competitor makes 1 cake in each stage. You can read the rest of it. The weights are the number of points that he can expect. Each cake is also judged for how well it's decorated, and we're given the decoration points that he might expect there. Now notice, that doesn't represent all of the different paths on here, does it? It only represents a very small number of them. And it does say, if it's not in the table, he expects to get 0. So 0 for any cakes that are not listed below. That's important. Okay, so quite a few paths in there, also 0. And calculate the number of decorating points that he can expect if he makes the cake given in the solution to part 1. So our solution to part 1, let's look at this, was 0, 0 to 1, 1. So that would be a 0 points. Then it was 1, 1 to 2, 1. 1, 1 to 2, 1 is 0 points as well, it's not in the table. Then it was 2, 1 to 3, 1. 2, 1 to 3, 0, sorry. 2, 1 to 3, 0, that's 1 point. And then it was 3, 0 to 4, 0, and that's not in the table. So it's 1 point. I actually made it really clear how I'd worked that out. Well, not really clear, but I wrote 0 plus 0 plus 1 plus 0 equals 1 point. But I think you could get, it was only 1 mark, wasn't it? You got the 1 mark, just saying 1 point. When Ken meets the other competitors, he realises that he's not good enough to win the competition. Poor Ken. Story of his whole life. So he decides instead to try to win the judges' special award. For each cake, the absolute difference between the score for cake making and the score for decorating is calculated. The award is given to the person whose biggest absolute difference is least. So that's really, am I right in thinking that's the person who is most consistent, even if they are consistently rubbish? Is that what we're looking for here? So the person who just makes the most appalling cakes and can't decorate them would get a special award. I could win that. Right. So a sympathy award that's what it is, isn't it? Right, draw the graph that the tabulation represents. Right, well look, in our in our table, we've only ever had 2 choices, have we? Tableau. We've only ever had 2 choices as we've gone through this. So it's a really simple network when we come to draw it. The network we have is, we've got 0, 0, and 2 paths leading from that. Those 2 paths are 1, 0, and 1, 1. And then we have 2, 0, and 2, 1. And each of them can go to each of the others. And then we have 3, 0, and 3, 1. And then we have 4, 0 at the end of it. It looks like that. Now, I'm running out of space a little bit for this. You need to draw this fairly big, because we've now also got to add our working values onto this. By the way, I don't know if, I can't remember if the mark scheme was happy about this or not, but I put direction arrows because there are directions on these, aren't there? You can't move in either direction along these arcs. So I did that. Now, this, that was, yeah, make the graph into a network by weighting the arcs with the absolute differences. I thought this was actually surprisingly challenging. You had to be comparing your initial table that had all the values in there with the little table of scores that they've got and work out the difference between them all the way along. Right. So, we start at the bottom of the table, don't we? 0, 0 to 1, 0 and 1, 1. They're those 2 actions. Now they are point scores of 2 and 2. We get that from that bit down there in the initial table. And 2 and 2, well, 0, 0 to 1, 0 scores 1 decorating point. So that makes that absolute difference 1, and the other one absolute difference is 2. So when we come to draw this on, it's going to be awkward to be zooming between the 2 of them here, but we have 1 there, and we have 2 there. Does that make sense? We've then got, if we look at the 1, 0, 1, that's that box. On 1, 0 it would be 1 and 0 for the 2 options, the 0 option and the 1 option. So that's his point, but we also need to look at, does 1, 0 lead us to any other points? Well, it does. 1, 0 to 2, 1 is 1 point. Now, this is quite hard to explain, isn't it, what's going on? So that was 1 and 0, but we also got 1 point there. So that means that has a difference of 1, and that has a difference of 1. So we've got 1 on both of those arcs. Can we see how we're working this out? Down here, we had point scores of 0 and 1, but that one had a decorating score of 2. So 0 and 1, but that had a decorating score of 2, so that's 2 and 1 on that path. 2, 0, that was 1 and 1, but we have a decorating score in both of them of 1, so they are both 0 on those paths. 2, 1, we have 3 and 1 as the two scores there and there, and that one doesn't have a decorating score. Oh yeah, it does, sorry, I've missed it. That one has a decorating score of 1, and that has a decorating score of 1, so that makes that 2 and 0 instead. And the final path, we don't have any decorating scores for the last stage, but we do have point scores of 1 and 2. And yes, that did agree with what I got last time I did it. So that's our table now. And then it says, for the final part, use dynamic programming tabulation to find the minimax root for the absolute differences. We want to minimise the maximums. Okay, we want to minimise the maximums. So the working column is going to be the maximums. And this is where we get to minimax those values. Okay? We're minimising the maximums. So we need to work out the maximums in order to minimise them over here. So let's see if we can see all of that on the page. Does that give me enough to go on? It does. Right. So here we go. We start from the back, we work forward. This is just 1 and 2 in here. So these are 1 and 2, because there was nothing to compare them with. Here, we're looking at the maximum of, this is 2, 0, isn't it? So that is 0, and the 0, 1 option is 0 as well, and we're comparing them with 1 and 2. So that is 1, that is 2, which gives us a mini-max of 1. Does that make sense? In this box, we are maximising. Now, what are these values? These are 2 and 0. 0. And we're comparing them with 1 and 2. So that gives us 2, that gives us 2, that gives us a mini-max of 2 at that point. This stage we've got 1 and 1 as our values, so we're looking at the maximums of 1 and 1, and the values we're working with are 1 and 2. So that gives us 1, that gives us 2, so we've got a mini-max of 1. And down here we've got 2 and 1, and it was 1 and 2 that we're working with. So again, that gives us 2 and 2. So we've got a mini-max of 2. And the final stage has us with 1 and 2 as the two values, and we're working with 1 and 2 as those values. So that's 1, that's 2, so it's 1 is our final value. The mini-max root has a mini-max value of 1. And the root, if we trace that back, we're starting at 0, 0. We're choosing option 0 there. In option 0, we're choosing option 0. In option 0 here, we're choosing option 0. And that takes us to 40 at the end, and that is the route. That's what you should do. That's all the marks. That's maths.